So welcome everyone to day 2 of JuliaCon. My name is Oscar and I'm going to be moderating this session. We're doing things a little bit differently for this keynote. We're recording it live now, but we will also restream it at 2:30 p.m. UTC. So if you're joining us from that later time, welcome. So the reason we're streaming this early is because our keynote speaker, Jeremy Howard, is joining us from Australia. Jeremy is a serial entrepreneur, the former president and chief scientist of Kaggle, and the founder of fast.ai, an organization that aims to make deep learning as accessible as possible. They have a Python package of the same name and various educational resources. And he recently released a new edition of his online course, Practical Deep Learning for Coders, which if he doesn't mention, I would encourage you to check out on YouTube. If you're watching us live, you can ask questions from this Pigeonhole link at the bottom of the screen, and I'll try and summarize them for the end. You can also chat in the green channel of Discord. Shortly, I'm going to add Jeremy's screens to the screen, Jeremy's slides to the screen, and then I'll pop out, and then I'll be back at the end to moderate some questions. So with that, Jeremy, over to you.
Thanks very much. So today I want to talk about what makes a programming language successful. And I'm going to talk about why I care about that, particularly for Julia. I've been coding for about 40 years and coding nearly every day for the last 30. And I've tried and used a lot of different programming languages. Julia is one of my favorite. As a programming language, I think it's quite magnificent, and presumably anybody who's involved in this conference must feel the same way. So I'm going to share some things that I particularly like about Julia. I guess everybody might have their own different feelings about what they like, but here are some of the things that I think are very, very special about this programming language. What you see on the screen here is actually a library I wrote for Python. It's a type dispatch library. In fact, it's called type dispatch. And as you can see, our examples of what is type dispatch and why it's interesting are actually in Julia. I like the way that method dispatch is handled in Julia so much that I wrote a library to try to copy it in Python. Having said that, my Python version is never going to be as good as the real thing. The way that type dispatch is done in Julia neatly solves the age-old expression problem, which has plagued computer science and software engineering for years, and allows us to really flexibly tie behavior to not just types, but to combinations of types. And I think that's really quite fantastic. And there's no other language I know of that handles this so well, including Python, despite the fact I wrote a library to try and do it. Having said that, if you do use Python, use fastcore because it makes it look more like Julia, which everybody agrees I think is a good thing. Something else I really like about Julia is a lot of the libraries are beautifully and elegantly designed. So for example, the library used for the very simple feature of calling out to the shell, calling external processes, is just better designed than really anything else I've seen, or certainly anything else I've seen that's built into the standard library of a programming language. So for example, running multiple commands in parallel in Julia, it looks just like it does in Bash. But it's real Julia. And then you can do really amazing things like piping parallel processes to another command. And I don't think I've ever seen anything quite like that before. And the whole thing is done in a very elegant way. There are simple, easily understood pieces that work behind the scenes together really well to allow you to express anything you want. Now, I mainly work in AI, and particularly deep learning nowadays. And as you might know, we do pretty much everything on GPUs or TPUs or accelerators. Something that is nearly unique about Julia is that we can write tight looping code that's going to run on the GPU in Julia. And it's not, there's less boilerplate than you would see pretty much in any other language. It just works. It just works beautifully. And part of so not only is that fantastic and important, because, in Python, we can't really do this. There are some libraries like Number which kind of let us do it, but it's nothing as elegant or as effective as this. And one of the key reasons this is possible is because of how elegant metaprogramming is in Julia. So the ability to do metaprogramming, to actually change how the code is compiled and run at the lowest level, and to write that in Julia is quite extraordinary. And so I think this is a very, special, capability of this language. Now, something that might be surprising to care about, but that I care about a lot, is that the vast majority of Julia is written in Julia. And the vast majority of the actual code that behind the scenes is being run when I create a Julia program is Julia code. There is, at the lowest level, a scheme-ish parser. There are bits of C and C++ for kind of doing interrupt with LLVM and stuff. But, most of it is Julia. And so, here's the type inference algorithm. Now, why do I care about this? Well, I care about this for a number of reasons. The first is I do a lot of teaching. And if I can't, debug into the actual code that's running, then it's very hard for me to show my students what's really going on. In Python, the vast majority of the code we're really running is actually written in C. We're just writing kind of Python wrappers on it. So if I'm trying to say this is what's actually happening under the hood, I can't do that, using a Python debugger. I can't use that using a Python IDE to jump into the code and explain it. And this is a real problem for teaching. This is also another reason that the GPU stuff's so important. I can actually show the GPU kernel code itself. It's more than that, though. It's also the hackability. So this is something that I talked a lot about with Chris Latner, who I worked with when we were trying to look at bringing fast AI and deep learning onto Swift. And he's the inventor of Swift and LLVM. And, he talked about this idea of hackability, a language where you can write all of the pieces of the language in the language itself, means that you can go in and change things and understand things. And this is just really important. I'm an academic, as well as teaching. I do research. I want to implement my ideas in code. If I have to, switch into C to do that, to be honest, I'm probably not going to bother. It's a whole different language, a different development environment. I have to worry about compiling and setting up, all that stuff. And it's just going to be a lot more verbose. In practice, in deep learning, very, very few of us in the research world ever go down to that level. But if I can write stuff in a higher level programming language like Julia, that's going to make a world of difference to the kind of research that I'm going to be prepared to do, because I can hack at anything. The package management in Julia is also terrific. Now, this is not unique to Julia. To be honest, the package management in Julia is nearly identical to a package manager in Python called Conda. But that's not a bad thing. That's a good thing. The Conda package manager for Python is fantastic. In both cases, it's not just Julia code or Python code that you can package, but all of the binary pieces, the libraries, the executables, and so forth. Versioning, dependencies, all handled as well. And so that is great news. I also love, by the way, that the REPL is a big part of Julia. I am a huge believer in REPL-driven programming languages and REPL-driven kind of programming methods. And I've written a lot of stuff for that in Python. So the fact that, there's even a separate package REPL, I mean, that's just super cool. So Julia is an amazing language with all these fantastic pieces, libraries, great ecosystem. So when you look at something like this, I mean, this is one particular listing of programming language popularity. Where's Julia? And the answer is it's off the screen, just behind COBOL. Now, nobody's going to say this is the world's most perfect programming language popularity listing, but there's lots of different ones, and they all basically show Julia being around about 25, 26, 27, and not improving, actually, in many cases, getting worse. So this is a bit surprising. This is a bit odd. What's going on? I think we all remember in the early days of Julia, the way we tended to think of this as being like, well, it's a new language. People haven't heard of it. People just haven't come to terms with how cool it is yet. But I don't think at this stage we can accept that that's the reason. So I spend most of my time working in Python, which is, according to this particular index, different one, the world's most popular language, and also growing the fastest in the last 5 years. I'm somebody who loves dabbling in all kinds of different languages, but there is something very nice about working in a very popular language, which is that when more people are working on a language, there's more stuff for it. There's more of the things that I want to do that somebody's gone out and done for me, or there'll often be multiple different versions, and I can find the one that works best for my needs. So here's what I want. I want Julia to be used more widely. Now, look, maybe not everybody feels that way, and that's fine. But that's my starting point. I like Julia. I'm a Julia enthusiast. I would like more people to be using it. Apart from anything else, the more people that are using Julia, the more people that are making it better, the more that's being invested into it, the more libraries that are going to appear for it. I think it's healthy and nice to be working with a programming language which is widely used. I personally want to use Julia more. In fact, today I use it barely at all. This may sound surprising, having given all this praise about how much I like Julia. But the truth is, much as I like the language, it's very hard for me to actually use it for anything in my work or even in my hobbies. And I think the reasons for that have got a lot to do with the reasons that few people are actually using Julia much out there in the world. And so I want to talk about the things that I think that maybe Julia could do to be more usable for me and to get more usage from other people. And as I say, these might not be goals that you share, in which case the rest of this talk will not be of interest to you. But if they are goals you share, hopefully you'll find these thoughts useful. So what I'm going to do is think about what makes a programming language successful. And to do that, I think an important starting point is to consider a particular kind of taxonomy of programming languages, which there's a lot of hand waving I'm going to do here, so bear with me. But hand wavily, I'm going to describe there as being two types of language. Those which kinda don't have a runtime, and those which do have a runtime or a virtual machine or whatever. Generally speaking, the main big difference between these will be about how they handle memory. So those that have a runtime are going to look after memory for you. Okay, so they're generally going to have garbage collection most commonly, including Julia. So Julia is a garbage collected language. Those without a runtime are going to do less for you. You're going to have to do more work. So in the case of C, you have to do all the memory handling yourself. In the case of C++, there's lots of different options, such as RAII. In the case of Swift, there's a very sophisticated kind of reference counting, which can happen at compile time. And in Rust, there's the infamous or famous borrow checker. Working without a runtime, is harder. It's more work. All of these languages are more difficult to use because of these issues around how you have to handle memory. And so Julia is in this class of languages which are generally going to be easier to use because they have a runtime looking after things like, in particular, memory for you. Now, why does that matter when we're thinking about what makes a language popular? Well, that's because these different types of languages make very different compromises, and they put them in very different places. So those that don't have a runtime, there's a lot you can do with them. So if you have to handle the memory yourself, it's kind of being handled at the compilation stage, so there's not a runtime, then you end up with an artifact which can be a totally self-contained app. Generally, it's going to be very small in size that you can distribute to somebody. You can even put it on a mobile phone. You could embed it in another app, even an app that does have a runtime, because remember, this thing's kind of standalone. It's handling all its own memory. Or you can do interop. So for example, Python, there are lots of packages designed to be used in Python, which are not written in Python. So for example, the company Hugging Face has a library called Tokenizers, which is very important in natural language processing, which is written in Rust. But the key audience for this package is Python programmers. And so because Rust is a non-runtime, again, hand-wavy, non-runtime language, it's very easy to use Rust from Python. That's definitely not the case of these other languages. So because these ones all have, a virtual machine or, their own kind of memory stuff going on in their runtime, they're not generally very good for any of these things. Generally, they can be done, but not necessarily going to be done well. So let's look at the group that Julia is in, languages with a runtime. So as far as I can tell, there are two broad classes of languages with runtimes that do well, that are popular, or at least popular with certain groups of people. One group are the languages which do everything pretty well. So Python does everything pretty well, Java does everything pretty well, Go does everything pretty well. They all have all kinds of constraints, all kinds of things that, you'd wish it was a bit better. As a Python programmer, there's 1,000 things in Python I'm not quite happy with, but I can do anything in it. Then there's another group of languages which do one thing really well. Languages like MATLAB, Mathematica / Wolfram, and LabVIEW, they have their niches where they can be very, very popular. And, another example might be something like K/Q/ KDB in the array programming world, used everywhere in hedge funds. These are kind of things that are fairly standalone. They're fairly niche. Generally speaking, nearly all of the languages I can think of in this category of doing one thing really well tend to be proprietary commercial languages. So it's often being marketed to a particular industry subsegment. So MATLAB, for example, is very widely used in engineering. As far as I can tell, this isn't really the direction that most people, I think, want Julia to go. So I think that leaves Julia in the category of like, or to try to do everything pretty well. So I'm going to call those flexible runtime languages. So the languages with a runtime that can do everything pretty well. And so here are 3 examples of very successful flexible runtime languages. So the first one we'll look at is Go. So Go, I'm kind of picking a few things for each of these languages, which I feel like are fundamental to their success. So for Go, you can create a standalone application. So remember, all of these are flexible, so they can do anything, right? But in particular in Go, you can create a standalone application. It's got a fantastic cross-compiler, so you can create it for any operating system and hardware platform in the list of supported ones. And that application that you create is going to start fast, and it's going to run pretty fast as well. So this is great because it can do anything, and then you end up with a thing that you can give somebody and say, here's a thing you can use, or you can chuck it up on your web server and your web server can use it. So that is a really nice set of things to have to work together. So what about Python? Well, one of the things about Python that's very interesting is it's pre-installed nearly everywhere, which is something that is also true of Perl, for example, although that's less popular now. So Mac comes with Python, pretty much every Linux distribution comes with Python. Windows, it doesn't exactly come with Python, but if you hit start and type Python, there's a link built into the system that takes you to the Windows store, Microsoft Store, where a single click will have it installed. So it's very, very easy for anybody to run a Python script. A second really important thing about Python is many or most universities basically use it as their starting coding language for most folks that need to learn to code. So we now have a lot of people in the world who know a bit of Python. And then partly thanks to these 2 things, and partly thanks to it's been around for a while, there's the most amazing package ecosystem for Python in that almost anything you can think of, there's going to be a few pretty good packages around. They'll generally be documented. They'll generally be maintained for doing whatever you want to do. So as a Python programmer, these are all things which are pretty interesting to this ecosystem. I love working with a language where lots of people know it because I can build things that lots of people can use. And that makes me feel good because I love building things that lots of people can use. Then there's Java, which apart from anything else, it's just been around a really long time. So it's developed a lot of users, and in particular, a lot of enterprise users. And it's got a really strong enterprise focus. So Java has a lot of inertia. And so there's just a lot of companies that use it. And also because it's been around a long time, there's a pretty good ecosystem of packages around for it as well. I wouldn't say it's anywhere near as broad and interesting as the Python ecosystem, but it's still pretty good. So these are all languages which have reasons for their success. And if Julia is going to be a flexible runtime language, what's Julia's reason for success going to be? So we've got, what do we got here? 1, 2, 3, 4, 5, 6, 7. Okay, it's 8 things for these 3. So here's those 8 things. Julia, let's see, what has Julia got? Julia is never probably going to get pre-installed on just about every operating system. It's probably not going to be the de facto education coding language. Getting an ecosystem as big as Python is probably not going to happen, at least not for a long time, and not unless it's very popular. Big enterprise like Java, probably not. Long history, I mean, that only happens over time, right? So that's not something that's going to happen in a hurry. So what we're left with here is – 'cause, 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 'c There's my little button here. There we go. So what we're left with here is maybe these three things. Standalone apps, cross-compiler, fast start. Maybe those are things that Julia could have. Now, these are the three things that all are in the Go category. And I think Go is very interesting for Julia because Go started in 2009. Julia started in 2009. Go is a garbage collected language. Julia is a garbage collected language. Here are two languages that both have the same basic approach to kind of memory management. They both started at about the same time. And I guess we got to be honest, Go's been a lot more successful. A lot of people are using it. It's, I think, in the top 10 of many popularity indexes. And again, like, popularity is not the be all and end all, but if more people are using our language of choice, then generally speaking, that's a good thing because more stuff's getting built for it and there's more people who understand it. And it's just nice to see things that we like doing well. At least that's how I feel. So it's, it's interesting to kind of look at Go as a role model of like, well, what did they do? And as I say, I think these three things are critical. And they're things which would make all the difference for me as a Julia enthusiast who's not a Julia user. Because at the moment, I kind of find myself thinking, what do I do with my Julia thing that I build? Like, I want to create a web app I can put on a website or a program I can put out there for people to download and install. It's not a great kind of like, what do I do with it? In fact, here's an example of somebody asking, I'm new to Julia. I just started loving this language at first sight. Elegant, ... I built something. Now I want to convert it to an exe. Answer. This is the most feared question of the community. There is no real-world usable approach. Now let's compare that to what happens in Go. Save your file as main.go. Type this command. Okay, copy the binary. Now that is nice, right? That's a thing. And look, it's not only that, but I can pick here what operating system do I want to compile for, what platform do I want to compile for, and I end up with a single file that I can put up on my website, I can give to my friend, I can stick on my web server. I've built something that I can use and that people can use. That is awesome. That's what I code for. And so not being able to do that is a problem. Now, these are all things that people in the Julia community have tried to do things about, but nobody's quite put it all together, right? Into the like delightful developer or user experience that, usability is so important that I want to be able to type this, type a line of code. There's my file, stick it on the web server. That's what it needs to be like. And it kind of feels like a lot of the pieces are getting there, right? Now, there are pieces that aren't going to be a solution to this problem, like static compiler, for example. Julia is never going to be a great statically compiled language. But the pieces like, artifacts and, package compiler, and, there's all these pieces, maybe even things like the daemonizer. I'm not sure exactly what the components are, but there's a lot of components out there which maybe are just about ready to be at a point where you could do this. And, this would be the thing that I think would make so many people say, okay, we always knew Julia is a beautiful language. We've always known it's got beautiful libraries, and now I can build things with it which people can use. And it's not like Julia is going to be exactly competing with Go, because Julia fills in Go's missing pieces, right? For example, Go doesn't have operator overloading. So speaking as somebody that does a lot of mathematics, a lot of science encoding, not being able to use operators in the way that they're used in my domain is a nightmare. right? And I just wouldn't feel comfortable. I don't feel comfortable in a language that doesn't let me use my operators properly. It's also the Go type system is pretty basic, right? And Julia's is pretty rich. And then on top of that, of course, is the very elegant dispatch mechanism that we've already talked about. And this group of things together, along with the overall design of the language, lets me write concise, expressive code. Now, not everybody wants to work in such a language, and that's fine. Go has very intentionally decided not to go for concise and expressive, but to create something incredibly simple that might take a lot more to write, but maybe it's easier to learn, or maybe it's easier not to mess up. I don't know. Like, it's not the way I like to code, but I know there's a lot of people who like that about Go. But of course, there's a lot of people like me who don't, right? And in particular, for scientific programming, generally speaking, I want to try and write the code in a way that looks like the paper that I'm implementing, and that tends to be much more using kind of concise and expressive notation. And then on top of that, GPU programming or TPU programming or, accelerator programming, in my field in AI, that's just absolutely necessary. And Go doesn't really do that, or at least not in any comfortable way. And then put all this together, and these are some of the key ingredients for creating good scientific libraries. And Julia already has a lot of excellent scientific libraries. Go really doesn't. So Julia fits into a kind of a different place, right? And it's a place which there's nothing else there right now. Speaking of something, this is the thing I want. I want something with all of Julia's beauty, all of Julia's great points, but something that I can create something that people can use, right? And I think that there's hundreds of thousands, maybe millions of people in the world who want that thing. I want to go to a web page that says, type this one line of code, press enter, and there's the thing that you give people. So that's my vision of what I would like to see. I would like a language which is exactly like Julia in every way. Really nothing's changed, but the difference is that I can build software that I can give to people, that people can use, that I can use very easily to run a web server, to chuck on a website. It needs to start quickly, so that single file that I create with a single line of code needs to start quickly, not use too much RAM. It's okay if it's 20 meg, that's no problem. We can send 20 meg, SCP a 20 meg file to a web server, zip it up and stick it on Google Drive, chuck, make it in a GitHub release, whatever. Like, that's how Go binaries are. They're not small, but they start pretty quickly, and they don't use too much memory, at least compared to Julia, right? They are practical and they are usable. And I would love something just like that, but with all of the wonderful pieces of Julia thrown in. Okay, so that's my thoughts about where maybe Julia can fit in the world of programming languages. I think there's a key place for it to fill. I don't think it's quite there yet, but maybe it's not that far. And so if anybody has any questions, I would be happy to take them.
Thanks very much. I think that was a very interesting talk, and I'm sure it will spur a lot of discussion going forward.
I hope so.
One thing I had that immediately popped to mind at the end was you said that it doesn't matter if the binary is 20 megabytes, but what about, say, 200 megabytes? I think some of the package compiler things, if you do at the moment, are kind of in that kind of order of magnitude. Is that a problem?
Yeah, I don't know. I mean, it's getting to the problem stage, not necessarily. Like for something I'm chucking on a web server, maybe not, like that feels okay. For something I'm putting as a GitHub release, like you don't want it to be at the point where like GitHub's going to be saying like, oh, that needs to go in large file storage or whatever. I can't remember where their limit is. I think it's still probably okay. Yeah, that's in the like, I'm not quite sure. It's close to the limit of what you could get away with. It'd be worth trying.
But ideally, we should be aiming for 20 or less.
Yeah, or maybe 50. Yeah.
Another question that came up was, how important do you think having a corporate sponsor for the languages? So Go and Java have had quite a lot of commercial backing. Python, I guess, hasn't historically, but in recently it kind of has more people joining in. But how much of that is an important factor?
Yeah, I think Python's a good example of like not needing corporate sponsorship if you are a really flexible language that everybody wants to use. Because then you end up with thousands of corporate sponsors. They're all people that are using your language every day and need it to be successful. You could say the same about Linux. You could say the same about LLVM, and like LLVM and Clang, I guess they're kind of, well, I mean, they don't really have a corporate sponsor. So I think like what's important is to have users, to have users that are using it for stuff that people care about, building software that people use. So not just users, but people who build things that themselves have users. And, speaking as somebody who develops a lot of software packages, we try very hard to highlight the big companies that use the code that we write, because we know that's going to give people comfort of saying like, okay, so for example, just today we launched a new version of our library for literate and exploratory programming called NBDev. And, we really highlighted, the companies like Netflix and Lyft and so forth that use NBDev on our homepage, because, we feel that people knowing that these companies are using this, they're going to be making sure that it works well, that they'll be putting time into keeping it, maintaining it and so forth.
So I had another question. So we compared, say, Go and Python and Java. What about R? That seems to be a kind of another language that's similar to Julia, trying to do statistical and mathematical stuff. How does that fit in?
Yeah, I mean, R, okay, so R comes from S, and S was originally available to, in the public as S+. It's got history on its side. It's been around for a long time. So when I started doing statistical computing, it was actually before even S+ really was out there. And in those days, it was kind of SPSS and SAS. They were very expensive systems that none of us particularly liked. And when S+ came along, that felt like a big step. And so for statistical computing, that felt kind of like a bit of a monopoly, that was the thing that you wanted to use. And then when R came along, it's like, oh, it's the same language that we've already been using, but now it's free, and open source. And so we all switched, or at least I switched, and everybody I knew switched to R. So that's a language which has kind of this base because it kind of had a monopoly, and it's been around for many decades. A lot of people I know that use R today use it for a couple of reasons. The first is, that's what they've always used. That's what everybody at their university or whatever uses, particularly popular in kind of academic circles. And also, it's a lot of it's because of one man, which is Hadley Wickham, who's created a set of beautiful libraries that have a better developer experience for kind of data munging and stuff like that than any other language. And I think also a lot of it's got to do with RStudio and JJ Allaire, who have built a fantastic free development environment in RStudio. But even that, I'm not sure that R is going to keep thriving. You may have seen is just today, RStudio renamed to Posit, because it's now going to focus on Python more. Increasingly when I talk to people using R, they almost sound a bit apologetic about it, and they're kind of like, oh, don't worry, I'm going to start learning Python soon. I know that I've got to. So I think that's an example of a language that's actually maybe a bit too niche and hasn't quite got what it takes to really continue to thrive. We'll see. I'd be happy to be wrong. Like I say, I do feel like Hadley's libraries are the best in the world for doing what they do. But personally, I used to use S+ and R, for all my statistical work, and now I never ever use it. So that probably gives you a sense of how much in the end, I really did or didn't enjoy the language itself.
I'll say that I'm coming to you from Auckland, New Zealand, so I can't say anything bad about R. One question is, what's your relationship to the fast.ai.jl package?
To the fast.ai.jl.
So there's a Julia package called fast.ai.
.jl.
How does that fit in?
Enthusiastic supporter. That's all. I think it looks very impressive. So fast.ai.jl is a, idiomatically Julia reimagining of the fast.ai Python library for deep learning. And, we went through a similar experience when we tried to create fast.ai for Swift, or we did create fast.ai for Swift, which is that languages like Swift and Julia don't lend themselves to the kind of highly dynamic approaches that we use very extensively in our code for fast.ai. And in Swift, you kind of got to use more of immutable stuff pretty much everywhere. And in Julia, I guess there was a bit of decision to go down that path. And so I think, they've ended up with a very, very, very interesting package. It's still fairly incomplete. It would be great to see it get more love. It's been mainly the hard work and passion of one person in particular, and I think it's amazing what they've achieved so far. And I would love to see it, go even further.
I think procrastinating grad students have built most of the Julia ecosystem. So one question was, can you expand on your thoughts about why Julia may not be competitive for teaching?
Oh, I think it can be competitive for teaching, but just like, I don't think like you're going to get into the first year university course as the first coding option for every university in the world in the next 5 years. Like that's something that happens after a language is hugely popular and has been for 10 years. So before Python, it was Java. All the introductory courses tend to be in Java. And then I guess after a while, people started noticing like, gee, there's a lot of boilerplate in Java and you're messing around with all this kind of compilation and virtual machine and blah, blah, blah. People started trying Python because they've seen it being popular for a long time. It's widely used in industry, and they realized they could teach, explain how to create a web server, or how to create a command line application, or how to create a GUI in just a few lines of code and focus on those. I think Julia could absolutely do those things, but it would first need to be one of the world's most popular languages, and then be in that position for 10 years, and then you might be in the situation where everybody uses it for teaching.
Okay, that brings us to the end of time. So I want to thank Jeremy for giving a very interesting talk, and I'm sure that there will be a lot of discussion going forward on some of the topics that were raised. So thank you, everyone. Enjoy the rest of your JuliaCon.